this is the flow chart that I was talking about. Okay, I think I posted this back on 4.4 a couple of weeks ago. If you don't have this, or if you never printed it out, I did post it again on this lesson in this practice worksheet. So if you want to print it out, by all means, go ahead. If you just want to follow along on your screen, that's cool too. All right, guys, ready? You're probably more ready than I am. All right, let's do a couple of these. This should be refresher stuff. If you notice on your flow chart here, the first thing you have to do when you go to factor a quadratic expression or equation is check to see if you have factor out any common terms. Now, most of the times, as you well know, from the previous section, I think 2 sections ago, we had 3 different forms of quadratic equations. With factoring, they're going to be working with the standard form. Y equals ax squared plus bx plus c. That's 99% of the time, that's the form you're going to be using. Okay. So the first thing we have to do here is when we go to factor, put in factor form, we want to factor out any kind of common term. So the way I do that is I look at the numbers, then I look at the variables. Okay. So looking at the coefficients 5 and 35, I notice that there's a 5 in each of them. So I know I can take out at least a 5. And I can also, then I look at the variables. I can also, this one has 2 n's, this has 1 n. So I can take out an n. Now we're undoing the distributive property, right? And we would normally multiply. So if we're undoing it, we're going to divide. So I'm going to take 5n squared, divide it by 5n, I get 1n left. Then I'm going to take my positive 35 and divide it by 5n, and that's going to give me 7. 35 divided by 5 is 7. The n's cancel out. So that's my answer. Okay. All right, let's look at number 4. Again, the first thing I'm going to do is see if I can factor out any common terms. And I'm looking at the numbers, and I have a 2, a 14, and a 20. And I notice, hey, I can take a 2 out of all of these. Then I look at the variables, 2 n's here, 1 n there, no n's here, so I can't take out n's from every term. So I then go ahead and divide every term by 2. 2n squared divided by 2 is n squared. 14n divided by 2 is 7n. And then 20 divided by 2 is 10. Okay. So then I'm not done yet, because I can factor this quadratic. It's got 3 terms. I'm going to ignore the 2 for now, because that's my common factor. So then I follow my flow chart. Hey, what type of polynomial do I have? Is it 2 terms, 3 terms, or 4 terms? This is 3 terms. So I go down here, and I'm looking at my lead coefficient, or my A, right? If my A is 1, then I can use that diamond, the easy diamond that you learned in freshman year, right? That you had to do like 200 problems. Okay, so here's that diamond. I call it an X because it's more of an X to me than a diamond. What they usually used to do is they used to join the sides and then tilt it up and look like a diamond, but it's just too much work. So I use the X. Okay, this section here, now that's our C. Remember, we have an A, B, and a C, right? A, B, oops, A, B, and a C. I'm going to get rid of this. So my A, now be careful here because I screwed this up on my first hour. I'm using this trinomial, not this trinomial. Okay, so my A here is 1. My B is 7. And my C is 10. So this section, this top section, if you remember, is two numbers, or what's being multiplied to get our C. Okay, our C in this problem is positive 10. Okay? And then this section down here, we get by adding the two factors of this number to get B. So my B in this problem is positive 7. So then I go back into my multiplication. I look at the factors of 10. 1 times 10 and 2 times 5. Now, these factors, I have to have two of them, obviously, to multiply to get 10. I notice it's positive, and there's only way, well, there's two ways. I was going to say one. There's two ways to multiply two numbers together to get a positive. And that's either a negative times negative or positive times positive. But don't forget that we are going to add those two factors to get this number, and that's positive. So these numbers have to be positive because they multiply to get a positive and add up to get a positive. And, oh, this should be a 5. And look, so that means I'm going to be adding these numbers together. And the two factors that add up to 7, obviously, is the 2 and the 5. So those become my factors for this trinomial. Okay, I have n plus 2, and then n plus 5. Don't forget to bring down the common factor we took out. And there's my answer. Okay. Let's continue on. I'm going to come back to this Diamond Xbox method, or whatever you call it, because there's a little hiccup in that. All right, let's look at the next problems, 5 through 8. You notice here, I have two terms. Okay, so if I go through my chart here, let's look at number 5, for instance. Can I factor out any common factor between 16 and 9? And the answer is no. And it's like, well, what type of polynomial do you have? And I already said it's two terms. So is it, then you ask yourself, follow the flow chart. Is it a difference of squares, a sum of cubes, or a difference of cubes? Now, there's no cubes in this one, so it has to be a difference of squares. Well, it doesn't have to be, but it is in this case. So then I have to ask myself, well, is 16 a square? It is a perfect square. In fact, it's 4 squared. It's being multiplied to my n squared. And then 9 is 3 squared. So I can use the shortcut formula on this, okay? Where I have a squared minus b squared equals a plus b, a minus b. Now, I have to figure out here what my a's are, my a and b. The a is what base is being squared. And here I have the base 4 being squared and the base n being squared. My b, I have the base 3 being squared. So then I can go directly to my shortcut formula. A, which is 4n, plus B, which is 3, and then A for n minus B, which is 3. Well, let's look at number 8 here. Yeah. So I'm looking at the numbers 80 and 45, and neither one of these are a perfect square. But so I'm saying like, well, that can be, can't use a shortcut formula. But I bypassed or skipped the first rule, right? Is there a common factor I can take out? And if you look at this, well, it ends in a 0 and a 5, so I know I can take out at least 5. And I'm trying to run the numbers through my head and thinking, well, maybe I can take out more than 5, and I don't think so. So I'm going to go ahead and take out a 5 and see what happens. 80 divided by 5 is going to be 16 n squared, because 80 divided by 5 is 16, minus 45 divided by 5 is 9. Now I have perfect squares. 16 is 4 squared, and 9 is 3 squared. So my A is the base 4n, and my B is the base 3. It's exactly like this problem. Don't forget the 5, though. Well, I shouldn't say exactly, because we have a 5 out in front. 4n plus 3, or n minus 3. Okay? Now, here's the kicker. If you're going into pre-calc or calculus, the pre-calc and calculus teachers won't ever go through this method, this Xbox method. Okay? They're going to make you do what's called mental math, guess and check. Because at that level, they assume that you know how to do factoring like the back of your hand. So what you're really doing is you're doing the FOIL process in reverse. So they look at this problem here and they'll say, well, there's only one way. Now we're not going to do the diamond. So they're gonna want you to go straight to the factors. There's only one way to get v squared. Now your first, following the FOIL, is v times v. So that's v squared. Okay. I like to look at the signs next. I got a positive being multiplied to a positive, adding up to a negative. So these have to be negative. Now the factors of 18 that are going to, since these are the same signs, they're going to add up to 11. So the only ones that are going to add up to 11 are 2 and 9. Okay. Now they will, the teachers for the higher mathematics, will let you use what they call arches to check, or if you're having trouble during the process, to do this. So these are your outer inner of the FOIL process. Okay. So if you multiply the inner, I get negative 2v. If you multiply the outer on this arch, you get negative 9v. And if you add those together, you get negative 11v, which is your middle term. Now, why they let you do this and not this, I don't know. I like doing the X thing if I had to do a method. Okay, my A is 1, my B is negative 7, my C is negative 18. So this is negative 18. This is negative 7. These are two numbers being multiplied to get a negative, so one has to be positive, the other negative. Positive times negative is negative. Factors of 18 that are going to subtract, because these are different. Let's see, you got 1 and 18, 2 and 9. Actually, since these subtract, 2 and 9 is going to work fine. It was 3 and 6. I want the bigger number to be negative because it's going to have to be a negative as a final product. So I have negative 9, positive 2. And there's my factors. K plus 2 and K minus 9. Now, these two problems, you could probably pretty much do it in guess and check and do your arches here. But when you get into a problem like, well, 11's starting to get a little difficult to do it with arches. So let's try it. Okay, one way to get 3a squared. In fact, there is only one way. Let's take 3a times a. That's the only way you can get 3a squared. Okay, two numbers that multiply to get a negative 15. So one's going to be positive and one's going to be negative. The problem is, one of these, when we do our arches, is going to be multiplied by 3 first. So I don't know if I'm going to have a positive here and a negative here, or a negative here and a positive here. So now things are starting to get a little difficult with this guess and check method. All right, factors of 15. 1 times 15, 3 times 5, and that's it. Okay. Now, if I use the 1 and 15, I'm either going to have 15 times 3, which is 45. That's just way out of the norm to get that 4. So I'm going to start with my 3 and 5. If I put 3 here and 5 here, when I multiply and use this arch, I'm going to get a 15. And this one, I'm going to get a 3. And I need to get to 4. So I'm going to subtract these. There's no way I'm going to get to a negative 4 if I subtract those. So that's not going to work. And then I'm going to switch them. I'm going to put the 5 here, the 3 here. This one's going to give me a 9a. This one's going to give me a 5a. And because they're different signs, I'm going to be subtracting. And 9 minus 5, I could get a 4. I want this to be, my bigger number to be negative. So the sign here better be negative to get my negative 9a. And then this one needs to be the positive to get my positive 5a. So there's my answer. 3a plus 5a minus 3. There's the guess and check method. A lot of work. You got to get lucky sometimes. It gets worse when we get into a situation like 13. Try to do the guess and check method on this. Well, now you have several opportunities to get that 10 in there. So it's 1 times 10, 2 times 5, could be 5 times 2, 10. So, yeah. I mean, the teacher's going to expect you in pre-calc for you to do it that way, but for most of us, we're going to use slide and divide. Okay. Which is on your flow chart. 3 terms, coefficients not 1. So you could do the whole guess and check thing or slide and divide. We're going to try slide and divide, see how that works out for us. Okay. So my A is 10. My B is positive 13, and my C is negative 3. Okay, so step one, take A times C. Step one, my A, 10, times C, negative 3, gives me negative 30. So that's my new C. Okay. So step two, I'm going to drop the A and replace the old C with the new C. Step two, going back to my equation, my expression, I'm going to drop the A. So V2 plus 13V, and then add the new C, which is add negative 30 or minus 30. Okay. Now, I can use the Xbox thing here. Okay. This time my A is 1, my B is 13, so my B added is going to be 13, and my C is negative 30. That's a negative, so I'm going to have different signs. I'm going to have a positive times a negative to get a negative. So they're going to be subtracting. So I have 1 times 30, 2 times 15. Look at that. I'm going to be subtracting. That's going to give me 13. In fact, I want the 15 to be positive because I want a positive 13. So here's my factors. I have V plus 15, and then V minus 2. Okay, so this was step 3. Use the Xbox method to factor. No, this was step 3. So step 4. Make sure the new factors are simplified, then divide by the original A. So what we have to do in step 4 is to divide each one of these by the original A, which is 10. And then we have to simplify those. So I get V plus, let's see, 5 goes into 15 3 times. 5 goes into 10 twice. 2/10 is 1/5. Now that they're simplified, if they don't divide evenly, I slide the denominators over. If they divide evenly, I would just have V plus whatever that whole number is. So my answer here, 2V plus 3 and 5V minus 1. That is this factored. Now, seems like a lot of work. I'm sorry, I should have moved that up. Seems like a lot of work, but it's doable. Okay, you can do it. Whereas you can get very frustrated trying to do it this way. So that was revisiting 4.4. Okay. 4.5 takes it a step further in that you guys have to solve by factoring. So that means you get an equal sign, right? So what you have to do is you have to factor these and then set each one of these factors, this one has n, equal to 0. And then solve for the variable. This one I'm done. This one I'm going to add 7. So I get n equals 0 and n equal 7. When you have a coefficient here, when you're setting these equal to 0. 7n minus 2 equals 0. N minus 7 equals 0. Chances are you're going to get a fraction. Add 2, 7n equal 2, divide by 7. N is going to equal 2 sevenths, and n is going to equal 7. You could also abbreviate this to n equal to 7ths, comma 7. Either way. Okay, so the rest of them, you're going to have to factor first, then set each factor equal to 0, solve for the variable. Told you it was going to take long. Any questions, guys? I'm missing Itai. Any questions on factoring? Were you guys able to see the document camera okay? All right. Don't have any questions. You can go back to sleep. I won't bother you anymore today. Have a good day, everyone.